I want us to move to this next theorem called the Proportionality Theorem. When we abbreviate it, we say it's the Proportionality Theorem. But what is the theorem actually saying? The theorem says if you've got a triangle, any triangle, remember that the triangle has got 3 sides and 3 interior angles. Now the theorem says that if you've got a triangle, and in that triangle there's a line drawn perpendicular to one side of that triangle. A line drawn parallel to one side of a triangle divides the other 2 sides proportionally. We've got a scenario here, a triangle ABC. Then there was a line drawn parallel to BC. So the other 2 sides becomes important. Let's read the theorem once more. A line drawn parallel to one side of a triangle divides the other 2 sides proportionally. So these 2 sides becomes important because these are the sides that are divided in the same proportion. If it is drawn parallel to this one, the other 2 sides become important. Let's make another scenario quickly. If we have got a triangle like this one, you can draw it parallel to this one. Now, there's a line drawn parallel to, it does not necessarily have to be parallel only to this one, standard position. It can take any position. It can be drawn parallel to this one, then these 2 lines becomes important. Or the other way around. We've drawn it parallel to this one in the first one. In the second one, let's draw it parallel to this one. You must be able to see that all these 3 means one and the same thing. A line drawn parallel to one side of a triangle divides the other 2 sides proportionally. So those other 2 sides becomes vitally important. Now the proof of this is required in the exams, so let's get on with it. A line drawn parallel to one side of a triangle divides the other 2 sides proportionally. What does that mean? When you've got a line drawn parallel to one side of a triangle, divides these other 2 sides in the same proportion. Let's write that down. This is saying, what does dividing in the same proportion mean? It means AD over DB is equals to AE over EC. This is what it means, and we must be able to prove this, whether it is true or not. But there are so many other options that we can, depending on what the problem is requiring you to find. We can have another option like, let's take the other option, AB over AD, you do the same thing on the other side, AC over AE. We can have as many options as we said, AC over AE. This can be required as well. But for this exercise, I want us to look at the first one. This one, I want us to go over it. I want us to prove this part. This is what we are required to prove. AD over DB is equal to, let's do it, AD over DB is equal to AE over EC. Remember, this line was drawn parallel to this one. Then these 2 sides becomes important. That's where we get this information from, proportionality theorem. That's what we want to prove. Remember what I said to you earlier on, theorems get on top of each other. I want us to prove this theorem using this one. Now, if you don't understand this one, you'll find it difficult to do the proof using this theorem. Remember what this theorem says. Triangles with equal altitudes have the ratio of their areas equal to the ratio of their bases. Even if, I said to you, even if we put it in this form, can you see the 2 triangles? This triangle and this triangle. Can these 2 triangles have the same altitude? Yes, they can have the same altitude. What this theorem will say the area of this triangle over area of this triangle is equal to this base over this base. This side, the area of this triangle over area of this triangle is equal to this base over this base. This side, the area of this triangle over area of this triangle is equal to this base over this base. That's what we are proving here, and we proved it, that it is true that triangles with equal altitudes have the ratio of their areas equal to the ratio of their bases. That's exactly the theorem that we'll be using to prove that. How do we do it? Now, I know that for this theorem to work, I've got to have 2 triangles with the same altitude. Then I can conclude that this area over this area is equal to this base over this base. Let's get on with it. What do? Let's have construction. Let's go with you step by step. Let's have our construction. Remember, the construction is always in dotted line. A line drawn parallel to one side of a triangle divides the other two sides proportionally. There are two sides that are very important here. If it is drawn parallel to this one, then this side and that side are important. Then those are the sides that I'm going to utilize. I'll start with one side, then go to another side. What side am I going to start with? I'm going to start with side AB. I'm going to use AB as a base. This is important. I've got to use AB as a base. Step number 2, I'll be using AC as a base. What is a base? Look at this triangle here. Triangle ABC. I've got two triangles, ABC and ACD. The base of triangle ABC is BC, and the base of this triangle is CD. So in this part, I've used this as a base, but when I tilt it this way, this becomes a base. When I tilt it this way, this becomes a base. So when I'm talking about a base, I'm talking about this or that or this. Now, if I want to use AB as a base in this particular case, how do I do my construction? I'm trying to create this, that, or this in that theorem. This is what I do. I don't just go and put pirates or crossed lines anyhow. I must understand what I'm doing. I'm trying to create this theorem out of that one. So this is what we do. You do this construction. Once you do that, let me remove this so that it will make much more sense. We'll take this back. We've got the luxury of our duster here, so we can take this back so that I explain it better to you. Once we remove this, you must be able to realize this theorem there, this part of the theorem, because this is a base in this particular case. Now, this is a base, this is a triangle, this is a triangle. What is this theorem saying? Area of this triangle over area of this triangle is equal to this base over this base. I know that fact and I can see it once I remove it. So I just don't go and put these diagonals anyhow. I do it for a purpose. Now, another problem. This theorem says triangles with equal altitudes. So it means that we need to create altitudes, perpendicular height. Remember, this is the base. The height will come here to the highest point. So if this is the base, this is the highest point, I will create my altitude. Let me call it H. This altitude is for, okay, I'll put it back here. This altitude is for this triangle and for this triangle. Now, both those triangles have got the same altitude. Now, I can use the theorem that says triangles with equal altitudes have the ratio of their areas equal to the ratio of their bases. Let's write that down. From this theorem, we know that area of triangle, what? ADE over area of this triangle, BDE, you can call it anything, BDE is equal to area of this over area of this, equal to that base over this base. What base is that? It's AD over this base, which is DB. Where did I get this one from? From the theorem that talks about equal altitudes. Triangles with equal altitudes have the ratio of their areas equal to the ratio of their bases. So this area over this area is equal to that base over this base, since both these triangles have got the same altitude. Right, that's what we have. That's what I wanted to, that's the first step that I wanted to get. How did I find this one? I found it using this side. Remember that before we cut it out, it was something like this. It was A, B, C, so this is C, right. So your paper will just look like this for the first part. I want us now to use the other side, AC, as a base. We must do the same thing as we did there. Let me take this one out for the case of explanation. Let's take it out, as if it's not there at the moment. Now, Step number 2, I want to use AC. This is where AC is. I want to use AC as a base. If I'm using AC as a base, my construction should come from C up to there. Right, that is what it will look like. Remember, I want to create this scenario where this is a base. I've got to create 2 triangles with the same altitude. This is the triangle, this is the triangle. They've got the same altitude. So I take this one out. I assume as if it is not there, though it is there, so that I can see my theorem clearly. I've got 2 triangles now, this triangle and this triangle. I know that if I can have the same altitude, it will go there. This will be the equal altitude for this triangle and for this triangle. This triangle, this is the altitude, and for this triangle, this is also the altitude. So both triangles have got the same altitude, and we know that triangles with equal altitudes have the ratio of their areas equal to the ratio of their bases. So this area over this area will be equal to this base over this base. Let's write that. We are now saying area of triangle ADE, area of triangle ADE over area of triangle, we said ADE over this one, CDE is equals to area of this over area of this got to this space over this space. So it's AE over, so it's this base over this base over EC, over EC. Right, reason equal altitude, equal altitudes. Right, this is very important. Once we come to this stage, half the battle is won. Now let us remember what we are required to prove. We want to prove this part. We want to prove, remember, when you put it back, when you submit your paper, it will look like this. Let me just quickly show you how it will look like. Remember, you started with this construction. When you were using AB as a base, you had this construction, and the altitude was from here to there. Right, so the paper, your paper will just look like this. Remember that a line drawn parallel, these 2 are parallel lines. Let's not forget about that. Right, so this is what we have. Your paper just look like this. You don't just go and draw those lines without understanding what you are doing. So that becomes vitally important. We want to prove that AD over DB is equal to AE over EC. Watch here. What we want to prove is already on paper. We said AD over DB, we already have it here. AD over DB is equals to AE over EC. We already have it here, AE over EC. The idea was to put what I want to prove, to put it down on my paper. So I've got so in other words, I want to prove that this is equal to this, because that's what is given there. So this is brought in here. So I want to prove that AD over DB is equal to AE over EC. Right. But I know that this is equal to that, and this one is equal to that. But I want to prove that this is equal to that. Logic. If this is equal to that, and this one is equal to that, if I want to show that this is equal to this, I've got to show that this one is also equal to this one. If this can be equal to this, therefore this one will be equal to this, because this is equal to that and this is equal to that. Right, let's take it. So what we need to do to show that this one is equal to this one, we've got to show that this is equal to that one. But let's look at what we need to show. We need to show that this part is equal to this part. Because this part is equal to this part, and this part is equal to this part. If this part can be equal to this part, therefore that part will be equal to this part. Let's work it out. We want to show that this is equal to this. It is made out of 2 things. There is a numerator, there is a denominator. We want to equate these 2. Let's go to the first one. Let's look at the numerator first. What is our numerator? The area of triangle ADE. This is our numerator. The area of triangle ADE. Let's look at the numerator of the second one. The area of triangle ADE. Same thing. Area of triangle ADE, area of triangle ADE. It is the same thing. So half the battle is won. There's only one thing that we need to show that it is equal. the denominators. Let's go and check the denominators. Area of triangle BDE, area of triangle CDE, it's not the same. So if we can find a way to equate the denominators, therefore we can show that this is equal to that, therefore that equals to this. Remember, we want to show that this is equal to that one. Now, all that we need to do is to show the denominator that they are the same. This denominator and this denominator. Because the numerators are exactly the same. If we can show that these two are the same, we can conclude by saying this whole thing is equal to this whole thing. Let's come back to the diagram. There are things that I want us to look at which will assist us in proving this one. I'm just going to try and do it here. These are parallel lines. I want us to look at this triangle here. I want us to look at this triangle. Let's call it ABC. Because these lines are parallel, we'll call this the highest point, the altitude. Let's call it H. Let's create another triangle there between those parallel lines. I'll do it on dotted lines so that you can see it. This is another triangle. This is ABC, let's call it D. So this triangle is triangle ABC, and this triangle is triangle DBC. I've got two triangles there that are between the same parallel lines. Now, if I'm looking for the area of this triangle, area of triangle what? ABC. ABC. And I also want us to look at the area of triangle DBC. DBC. I want us to look at those two triangles. Those two triangles are important for us to go to the theorem. Now let's look at this triangle. What is the formula to find the area of a triangle? It's half base times perpendicular height. So the area of triangle ABC will be equals to half base. What is our base? It is BC times H times perpendicular height. Let's look at the other area of triangle DBC. It will be equals to half base. What is our base? It is BC times H. What do you notice about those two areas? Area of triangle ABC, it is half BC times H. Area of triangle DBC, it is half BC times H. These areas are exactly the same. So I'm trying to show you that if you've got triangles that are written between the same parallel lines and they share the same altitude, those areas will be the same. Even if I take this and put it the other way around, even if I put it this way, look here quickly, even if I put it this way, I have one triangle like this one and another triangle like this one. If these two lines are parallel, this area will be equal to that area because they are between the same parallel lines and they have the same altitude. So it is important that we should understand these facts. Even if I tilt it likewise, this area will always be equal to that area. Even if I put it upside down, this area will be equal to this area. Even if I tilt it this way, this area will be equal to that area. So it is important, if those two have the same base and they share the same parallel lines, then those areas will be the same. Now let's come back to the problem. Remember, we wanted to show that this whole part is equal to this whole part. Let's look, we said this is exactly the same as this one. Let's look at our denominators. What is our first denominator? This is the area of triangle BDE. BDE. We want to compare it with which one? Area of triangle BDE. BDE. We want to compare it with this one. We want to compare it with area of triangle CDE. CDE. Let's look at those two. Where do we look? We go to the diagram. Let's look at this area of triangle BDE in the diagram. Area of triangle BDE. It's this area. It's this area here. We're comparing it with which area? Area of triangle CDE. CDE. We're comparing it with this area. Look at this one. This one is between the same parallel lines and they share the same altitude. It is exactly the same scenario as this one. And we've already proven that this area is equal to that one. Hence, we can conclude that these two, because they share the same base and between the same parallel lines, they are equal. Hence, we can safely say these two areas are the same and state the reason. Same base, same parallel lines. Now, if then this area is the same as this one, and we can see that this one is the same as this one, so that whole thing is therefore area of triangle, what? ADE over area of triangle BDE is exactly the same as this one. Area of triangle what? ADE over area of triangle CDE. Right? We've already shown above, proved above, which this part, the denominator here is the same as the denominator here. This is proven here, and we can see that area of triangle ADE is the same as triangle ADE. So everything is the same. Now because this is equal to that, and this is equal to that, and this one is equal to that, therefore these two will be the same. Therefore, AD over DB will be equals to AE over EC. So this is how you go about proving this theorem called the proportionality theorem. A line drawn parallel to one side of a triangle divides the other two sides proportional. There are so many other methods, but I would prefer this shorter one, where you make these two sides the most important side. You first use this as a base, you apply the theorem, you use this one as a base, you apply the same theorem. Also know these facts. With triangles that are between the same parallel lines and they share the same base, their areas will always be the same. Thank you.